Okay, so we're starting chapter 3. 301 is vectors. So first of all, just some terminology. So a scalar is a quantity with magnitude only. And in the vectors topic, we tend to use the Greek letter lambda or mu quite commonly for those. Sometimes we'll use a t, but often it's Greek letters. A vector, on the other hand, is a quantity with magnitude and direction. We use a little squiggle under a letter, like A with a little squiggle. If we're typing, we might type it in bold. So just watch out for that one in an exam. It could come up, but you won't see it so much in written notes, so you don't see it so often when you're learning. We can have AB with an arrow at the top. The arrow shows the direction that it goes from A to B. So from A to B, it's going that way. So two examples. Speed is a scalar. We might talk about something speed in meters per second, whereas velocity, on the other hand, we have direction as well. So it might be 8 meters per second down. So we might have negative 8 meters per second. The negative, of course, refers to our frame of reference on which way is positive and which way is negative, but it has direction as well as magnitude. So the magnitude is how fast, and then the direction is which way it's going. So here's an example. We've got a person who walks 3 kilometres on a bearing of 100 degrees and then turns and walks 5 kilometres on a bearing of 260 degrees. How far are they now from their starting point? Now, we've seen these questions before. This came up in trigonometry. So we're going to be using the sine rule or the cosine rule, or we could just be using SOHCAHTOA. Now, the thing about vectors is we can just pick them up and move them. So if I just duplicate this vector here and move it down here, it's still the same vector. It's still going in the same direction. I'll put the arrow on in a bit. And then I'm going to duplicate this second one as well and move it down here. So what I've done is I've put them directionally. I've joined the tail of the second one to the head of the first one. So we knew this was north, so this was 100 degrees. This is 3 kilometres. I'm just going to draw a north line here as well. We know this is 260 degrees. Because the first one was 100, this will be 80 degrees because of co-interior angles, and this is 5 kilometres. And we can draw another vector between where we ended and where we started. And that's what we're trying to find. How far are they now from their starting point? So we need to work out the angle in the middle. We've got the 260 and the 80 angles at a point. This bit needs to be 20 because they all need to add to 360 degrees. So this is the side we're trying to find. So we've got 3 sides and 1 angle, so that is the cosine rule. So c squared equals a squared plus b squared minus 2ab cos c, because we're finding a side. So let's make the a equal to 3 and the b equal to 5. So 3 squared plus 5 squared minus 2 times 3 times 5 times cos of 20. Put that all in your calculator. Now remember, you can't do 3 squared plus 5 squared minus 2 times 3 times 5 and put that in your calculator. Because this is all grouped together, the multiplication has to come first, so that all needs to go in the calculator at once. Then, of course, we need to square root it to find c, and that's 4.66 kilometres to 2 decimal places. Now, also just as a side note, I could label the vertices A and B for our first journey and then a C at the end there. And we can actually do some vector addition here. So if I do vector AB plus vector BC, I do get vector AC. So it puts all of the journey basically into, as the crow flies, in that direction towards C. So in example 2, I ran 3 metres right, then 2 metres left, and lastly 7 metres to the right. Where do I end up? So let's draw some vectors to represent that. So we've got 3 metres to the right, then 2 metres to the left, and then 7 metres to the right. So I end up 8 metres to the right of my starting point. So we've got a distance there, a displacement. We've got it's a vector, it's displacement, it's got direction and magnitude, 8 meters to the right. What's the total distance I ran? Well, my distance is the 3 plus the 2 plus the 7. I ran 12 meters. That doesn't have direction, so this distance is just a scalar. So where displacement is a vector, distance is a scalar. Okay, so let's talk about like vectors. So like vectors are parallel and they have the same direction. So you can see some like vectors there. Unlike vectors, they are also parallel, but they have opposite direction. So let's look at the vector u, so that's 2 across 3 up. The vector v is 4 across and 6 up. The vector r, that is 4 across in the negative direction and 6 down. So -4, -6 is how we write that one. So if we look at u and v, they are like. If we look at u and r, they are unlike. If we look at v and r, they are also unlike. So like if they've got the same direction in parallel, unlike if they have opposite directions in parallel. Now let's also note that v is equal to 2u, r is equal to -v. They have the same magnitude but opposite direction. And you can really see that with these numbers here as well, that r is equal to negative of v. And also r is equal to -2u. So multiply this one by -2 and you'll get that one. Okay, let's talk about some types of vectors. So firstly we have a unit vector which has a magnitude of 1 unit. So here's an example here. It's 1 unit long. There are two special unit vectors, I and j. So I is the unit vector in the direction of the x-axis. The direction of the x-axis is that way, that's its positive direction. And j is the unit vector in the direction of the y-axis, so going up. There are displacement vectors. Now they're also known as relative vectors, direction vectors, or free vectors, depending on which book you look at. Any of those names could come up in a test, so I'd suggest knowing all of those. So if we look at these displacement vectors, they can be drawn anywhere. These vectors are equal, so vector A is equal to vector B is equal to vector C. So A equals B equals C. They have the same magnitude, they're the same size, and they have the same direction. So that makes them equal. They can be drawn anywhere. Free vectors or displacement vectors drawn anywhere. Now, in order to write them, we can say A equals 3 across 2 up. Okay, these are positive numbers, so the 3 stands for across and the 2 stands for up. So that's called a column matrix. We can write it that way. Now, we could also write it in component form. So where we say A is 3 lots of I plus 2 lots of j. So 1, 2, 3 lots of I plus 2 lots of j to get from the tail to the head. So as I said, that's component form. Next, we're going to talk about position vectors, also known as radius vectors. Now, they're always drawn with their tail at the origin, so they do need some axes. So this one is 2 across 1 up. So as a column matrix, we can write 2, 1 like that. It's very easy to accidentally put a vinculum in there that does not belong. In component form, we can write it as 2i plus j. So let's talk about negative vectors now. So they have the same magnitude, but opposite direction. So these two here are negative vectors. I did mention that before. So vector R, we could also call AB. Vector M, we could also call DC. Direction is from D towards C. So R is equal to AB. Now if I write that as a column matrix, that is 2, 5. So it goes across 2 and it goes up 5. M is equal to DC. So the direction is that way. If I write that one as a column matrix, it's -2 and -5. So always the horizontal first, then the vertical. Now the vector R that's equal to negative of m. They do have the same magnitude, but they have opposite directions. I could also say that DC is equal to negative of CD. Okay, the vector from D towards C is the opposite of the vector from C towards D. So remember that arrow is the direction that I'm talking about. So even though this picture is vector CD because of the arrow, I can still talk about CD as well. So the vector AB is equal to the negative of vector DC. Okay, AB going that way is equal to CD, and CD is the negative of DC. We can also say that AB is equal to CD, AB that way, equal to CD